Okay. And we are live on YouTube, although it looks like there's a slight delay. Everything that's going on up there. Gregorius says, how does the stream look? I can hear my own audio coming through someone's speakers, so that tells me that's working at least. Well, alrighty then. All right, good. Well, we'll go ahead and get started. We'll be taking questions from Stream Chat. So if you have a question about anything that we're covering on the roadmap today, just go ahead and drop it into chat. So this will all be recorded, and people will be able to go ahead and view it after the fact. But we will go ahead and get started right now. Okay. So just going to go ahead and introduce some of the people who are attending today. So I'll flip screens here real quick. So we have, let's see, Gregorius and Igor, who both work here at Petabridge with myself. So they've been working on Akka.net for quite some time. So we got both of them joining today from Indonesia and Russia, respectively. We have Arjun Smits, who's a longtime Akka.net contributor from Holland. So he's attending today. And then we have Andrew, who's also here from the United States. So we're going to go ahead and so they've already seen everything that we're about to present today, but they're here to help us talk a little bit about what is actually on the roadmap and what the value of it is. So we expect this to take maybe about an hour and a half to kind of get through all of it. And our goal is to kind of lay out the next couple of years worth of Akka.net roadmap to everybody. Okay, so let's go ahead and get started. So today we're going to start by talking about why we do what we do. So what's the purpose of the Akka.net project? Why are we here? And why have we been doing all this stuff for 7 years? Next, we're going to talk a little bit about the health of the project from an open source perspective. So how is our truck factor looking? What does our level of contribution look like, and so forth? We're going to talk about technical concerns in terms of these are things that users care about and have raised to us as issues that are either making life more difficult for them or things they would just like to see the framework do a little bit better than it does today. Then we're going to go ahead and spend most of the time today talking about the roadmap, the actual stuff we're going to try to do and when we're going to try to do it by. And then we'll spend a little bit of time at the very end talking about redoing the Akka.net website, the documentation, and the examples. So let's dive in. So why do we do what we do? It has been, I think the last time we held a public contributor meeting like this was early 2015, or maybe mid 2015. It's been a while since we've held one of these, but the Akka.net project has gone strong all throughout the meantime. And that's because we have a strong reason to entre, a reason why we exist. The primary reason why the Akka.net project exists is because we ultimately want to give .NET developers the best-in-class tools for doing concurrent programming in any environment. Now, even though primarily a lot of the stuff that I talk about, in Gitter chat and on the blog and other things you see lots of other Akka.net users asking questions about, the lion's share of those tend to be about cloud stuff, building SaaS services, that sort of thing. But there's also a huge community of users who use Akka.net for doing lightweight actor programming on embedded devices, inside Unity 3D clients, but also inside things like Xamarin applications. So the Akka.net project really exists to try to give those users the ability to use the actor model in all these different environments. The other big reasons why we exist are to import the exhaustively battle-tested and wildly successful designs from Scala and Java to the .NET ecosystem. So one of the big advantages of using a technology like Akka.net is that the designs that we're based on have had, let's say, millions of years worth of, let's say, in production time. If you go and add up all the different concurrent companies and the amount of utilization of this technology and everything else, there's a lot of data that goes and supports what does and does not work in that ecosystem. we feel that importing that knowledge into .NET is a valuable activity that will give .NET developers more tools and more ways to solve complex problems. We're increasingly moving towards a world where software has to be available 24/7, 365 across a much larger number of end-user experiences for a much higher volume of data that is traveling at a much faster velocity than it used to, with a much greater variety as well. So in order to handle all that increasing domain complexity, we need scalable designs that are thoroughly battle-tested that allow us to go ahead and adapt to the various changes in circumstances and ecosystems that are facing all of our companies. Akka.net is an example of a technology that I think can really help bring that to .NET developers. The other reasons why we exist is to provide a model excellence and open source experiences for large enterprises. So that's why we're really big on backwards compatibility, documentation, QA, and it's also why we offer professional support and why we're increasingly working on things like enterprise tooling. We want to go ahead and make sure that our open source project caters to a wide number of needs, whether you're a student trying to do something for fun or for educational purposes, or maybe you're a startup and you want to be able to adopt technology like Akka.net and build a proof of concept without spending a lot of money. We can support that. Or if you're a gigantic bank or a healthcare company and you want there to be guarantees of 24/7, 1-hour SLA support, we want to be able to cater to that entire spectrum of customers. Finally, the last reason is we want to go ahead and create an alternative to the monopoly of Microsoft technologies that dominate distributed computing in .NET. I've harped on this on Twitter for going on 6 or 7 years now, where I've talked a bit about how the open source ecosystem for .NET was effectively an intellectual ghetto around the time we started the Akka.net project. And this is because Microsoft had effectively, driven out a lot of the people who were involved in the alt.NET movement and folks who were really creative and thought outside the box. And Microsoft effectively drove a lot of those people out either through cannibalizing successful projects, discouraging open source adoption, or essentially encouraging users to be skeptical of it altogether. And as a result, by 2012, 13, 14, we ended up with an ecosystem that was way behind all the others. Now, .NET and Microsoft have turned a corner on that since then, particularly since they've really embraced Linux and cross-platform computing. But we still think it's important for there to be a range of ideas and ways of expressing those ideas that aren't all housed together in the same group of a dozen buildings in Redmond, Washington. So these are the reasons why we exist. Now let's talk a little bit about the health of the project. So we have 4 full-time team members here at Petabridge. 3 of us who are on the call today are regular Akka.net contributors. We've not been as active on the project recently as we were earlier this year. That's largely because we've been busy with the launch of SDK Bin, which is our sort of, let's say, NuGet meets App Store platform for marketing and selling proprietary products. So that's one of the reasons why we've been a little bit less active than we usually are. We've been trying out a 2-week sprint format where we switch between Akka.net and SDK Bin. Right now, we're actually in the middle of a 6-week-long SDK Bin sprint as we try to get some major architectural pieces across the finish line. But our last 2-week sprint that we did, which concluded a couple weeks ago, was very successful for Akka.net. So we're probably going to stick with that in the meantime. That way we can make sure that we're actively triaging issues and doing sort of regular work on trying to bring big new features across the finish line. We also have a number of regular contributors who work on Akka.net. Now I put this at 2. The real number is probably a little slightly higher than that, probably 3 or 4. But we also have a number of drive-by contributors who show up to patch issues they run into or or submit fixes to documentation and that sort of thing. So right now, the biggest problem the Akka.net project has is that Petabridge is really functioning as a bit of a bottleneck. We have a lot of other projects that we're working on concurrently right now. We're doing a lot of work on SDK Bin. We're doing a lot of work on Phobos, which is the component that we sell for doing end-to-end tracing and sort of observability stuff inside Akka.net. We've been doing a lot of work around that. So that's one bit of an issue right now, is that we have still a relatively small full-time engineering team, and so we're not making the type of progress that we would otherwise like to be able to do on major feature areas for Akka.NET. So that's something that we're hoping to try to address via our sprint system that we're working on right now. Ideally, though, we're going to solve this through actually hiring more developers at Petabridge, which we are actively doing right now. The other issue that we have with the project's health is, and this is really on me as sort of the kind of lead maintainer here, but the issue is that we haven't really done a lot to help organize people who want to contribute to Akka.NET. We haven't made it all that easy for them. In particular, we haven't done a lot of organization around these big milestones in terms of clearly assigning things to people, making it easy for developers to stick their hand up and say what they want to work on. We haven't offered a lot of, let's say, guidance in terms of how to do things like contribute documentation or make a major change to the platform. And so as a result of that, I think we've made it a little bit harder for people to contribute to the project than they would otherwise like. The last issue is, and this is definitely my fault, a regular cadence with the Akka.NET team meetings. We've gotten back, over the past couple months, we've gotten back on top of this, but throughout the course of this year, and definitely a little bit last year too, we've had these sort of every couple of weeks sort of Akka.NET private contributor meetings for going on 5 or 6 years now. Well, we've really kind of slacked on sticking with that time frame. And as a result of that, it kind of makes it hard for us to build up some momentum around big projects. So we're sticking with that now. And one of the things that should help is making these meetings public every couple of weeks. Because this is every month, excuse me. So every other one of our Akka.NET team meetings will be open to the public. And the idea is to help try to drive some accountability around some of the milestones that we're carrying. That way we can go ahead and make sure that users are getting their issues triaged, we're making progress against major features, and the Akka.NET project is getting better and better all the time. So in terms of our project health goals, what we're trying to accomplish for the Akka.NET project, the first one is increasing the Akka.NET truck factor. Now, if you're not familiar with what truck factor is, this is a metric used to measure the health of not just open source projects, but also companies. It's how many people need to be killed by being hit by a truck in order for the project to fail. And in our case, our truck factor is probably somewhere between 1 and 3 people right now, where if one critical person got hit by a truck, that person might be the only one who knows where all the publish keys are and everything else, and it might be really difficult for us to go ahead and actually publish new updates. But more realistically, the bigger issue tends to be things like who's actually to go and triage the bug if someone gets hurt or if someone becomes less active in the project. So you always want to increase truck factor all the time. So doing that requires attracting more regular contributors, making it easier for people to contribute, and then building some competency centers. So a good example, I just opened some GitHub issues recently on the Akka.NET project around doing some meta documentation, documenting our build system, documenting our release processes, documenting how we're supposed to actually organize the documentation. Putting some of these together can help make it easier for other developers to get in, figure out what they want to do, and learn how to do it without having to worry about one of the core developers in Akka.NET rejecting their pull request. We don't want to waste anybody's time if they want to contribute to the Akka.NET project. So these are things we're going to try to do to help increase the number of people who can contribute to Akka.NET. One other item that's not on this list is Petabridge hiring more people, which we're definitely working on. Now, the next bit in terms of trying to improve the health of the overall project is publishing our roadmaps for what we want to accomplish and trying to stick to them. So part of that's going to involve making every other one of our meetings open to the public, and then also doing more to publish our sprints when we're doing our 2-week sprints where we're working on Akka.NET. And then we're also going to do some more work around trying to go ahead and actually take our public roadmaps that we create and make it a little bit easier for developers to see what issues could I work on if I wanted to contribute to this. So for instance, if you're interested in learning how to contribute to Artery, which is the new Akka.remote high-speed transport that we're planning for Akka.NET 1.5, what are some things you can do to help us accomplish that sooner? These are some of the things that we want to try to publish. All right, so I think we've gone through a bunch of this. Let's go ahead and talk about the technical and project concerns. What are the issues that we're hearing from end users about things that are problems for them in terms of using Akka.NET? Well, I tried to document most of the ones that have come up in my consulting and training work that I do here at Petabridge, but also things we hear on Twitter, at conferences, on Gitter chat, on Stack Overflow. What are the issues that come up for end users? Dependency injection is outdated and doesn't support the Microsoft defaults well. The debugging experience is inconvenient. We want more performance. And then probably the biggest general concern about Akka.NET is the lack of type safety and program coherence around actor references. So we hear a lot of this from end users. HOCON is another big area where users have a lot of feedback. We want some way of statically type checking our configurations to make sure we did everything correctly. Our HOCON implementation is out of date and is still using a 7-year-old version of the specification. And on top of that, it doesn't really integrate with Microsoft.extensions.configuration all that well. For Akka.remote and Akka.cluster, again, performance comes up pretty frequently. Default serialization. This has been, so we published an Akka.NET 1.5 milestone back in 2016. This is before .NET Core came along and scrambled the entire set of priorities for the project when that came out. But default serialization has been an outstanding issue for a long time. Are we going to go ahead and finally move on to Hyperion? Are we going to stick with JSON? What are we going to do about making this easier and faster and more version tolerant, etc.? Reliable delivery, another issue that comes up a lot. This is one of the things that users tend to run into as a problem when they start really working with Akka.NET. Akka.cluster. The biggest complaint that I think I get from users on a regular basis is being able to visualize what's happening inside their cluster. How did I end up with only one node up and running? How did I end up with a split brain? Which nodes saw who go unreachable, and so forth. We have an answer for this, by the way. We're going to go ahead and get to that as part of the presentation today. Deployment's a big issue too. How do I actually deploy a cluster to production? How can I do continuous delivery? How can I make sure my seed nodes are sort of managed correctly inside a running system? And then finally, we have issues with multi-data center clusters. This is something that we at the Petabridge team are going to have to deal with SDK bin at some point in the future. Is if we want to be able to offer low latency experiences when users want to restore NuGet packages from SDK bin, we're going to have to come up with a way to host multiple instances of our NuGet service in multiple locations around the world. There's no getting around it. So let's see. The next couple of concerns that come up, a lot of the same ones. Akka.persistence, its performance, its serialization, its error handling. With Akka.Streams, its understandability, it's the lack of tutorials, and around it is probably the biggest issue. And then finally, there's the visualization and operations piece. How can I understand how does my Akka.Streams graph, when I put it together, how does it actually run? Where are the actual actor boundaries that get produced when I construct a stream? What is the reason why my stream performs differently than what I expect? What are the reasons for this? So these are some of the things that we've received as feedback from end users. Now, if you have some other things you'd like us to go ahead and address, the chat right here would be a good place to do that. So if you want to go ahead and bring some of that up, I can go ahead and try to address some of it, or maybe someone else on the team might, later on as we kind of get further and further into our presentation today. Now, this is what the roadmap looks like for Akka.NET 1.4, which we're working on right now, 1.5, which is planned for Q3 2021, and then Akka.NET 2.0, which is planned for Q2 of 2022. These are the high-level items that are going onto the roadmap. First, I've already put up a specification for some of this stuff on GitHub, but we're redoing DI integration for Akka.NET 1.4. It's going to use Microsoft.extensions.di at the center of it, and we're going to use the new actor system setup type to make it easy to pass in an externally configured DI container and consume it from inside Akka.net. And this might open the door for all sorts of other things that we might be able to do inside Akka.net. So that's one thing that we're going to do. Next, visibility and operations. We're going to introduce some new DevOps tools for making it a little bit easier to visualize what's happening, particularly inside your cluster. And then performance is another issue that we're working on right now. Andrew on the Akka.net development team is working on an Akka.Streams replacement for .NETty. That should be quite helpful. Myself and Andrew and one of our contributors, Zetanova, are all working on trying to fix some issues with idle CPU performance right now. But I think there's also an opportunity to really increase remoting performance out of some of this too. So we're working on all these things concurrently right now. Akka.net 1.5 is on the horizon. Gregorius on our team right now is working on a major Akka.net remote performance improvement project, namely porting the artery transport from the original Scala implementation of Akka. That's going to be a significant improvement. So today, using the .NETty transport with batching turned on my machine, I can get somewhere in the neighborhood of about 190,000 messages per second. Theoretically, with Artery, that number might be closer to 750,000 over a bunch of Akka.io.tcp connections. So we're going to go ahead and keep trudging ahead with this, but our hope is to ultimately make the experience of Akka.remote much more performant. We're going to finally introduce a multi-data center Akka.cluster. We're going to answer the default serialization issues with Hyperion here, or potentially something else. We're going to talk about that. And then standalone Hokon, which we tried to do for Akka.net 1.4, and we rolled that back because of the experience people had with it during our release candidates, was that it was fairly non-performant. We've learned from that. We know what we're going to do differently this time around, and we're going to gradually start introducing this as part of Hokon 3.0. So this should land by a beginning of October next year is our hope. The next big milestone, and this is the one I'm most excited about, is Akka.net 2.0, where we're going to introduce typed actor references. So the biggest issue that users have had with sort of general Akka.net, not including some of the performance issues that get raised periodically around Akka.remote and Akka.persistence, has been the lack of type cohesion. Namely that when you're reading an Akka.net codebase, it's not necessarily clear who does what when you're looking at all the actor references, because actor references are fundamentally untyped in Akka.net. That's going to change. And I actually have some pseudocode I'm going to use at the end of today's roadmap presentation that'll show you what typed actor references might look like in C#. Now, some of the other changes we're going to be making, or at least we're planning on making as part of Akka.net 2.0, are some major core performance improvements to Akka.net itself. So we're going to be changing the way dispatchers work, for instance, to probably use more things like value tasks under the hood. And we're probably going to be taking advantage of some of the new .NET 5 and .NET 6 primitives. That should allow the default throughput of all actors to increase pretty significantly. We're also going to be making some major changes to Akka.Streams in here as well, kind of building on top of some of what we're going to do with typed actor references. Finally, the last big change we're going to introduce for Akka.net 2.0 is we are going to end of life .NET Framework support then. So you have, don't worry, you have a fully, I think, let's see, not just slightly under 2 years before you have to worry about this, but we're going to go ahead and move on to supporting .NET 5 and .NET 6 directly at this point. That way we can take advantage of some of the low-level performance improvements that are being introduced to the newer versions of the platform all the time. And it'll go ahead and reduce the maintenance the sort of maintenance burden for us, which is that right now, if we wanted to go ahead and do dual support between .NET 5 and let's say .NET Standard 2.0, which is what we'd have to do to support some of this today, we would have to go back to doing dual compilation, which is what the biggest change between Akka.net 1.4 and 1.3 was getting rid of that, moving everything onto .NET Standard 2.0. We might still, it's possible, We might still potentially end up going back to dual compilation if there's a really compelling reason between now and then. But the plan is to go ahead and fully adopt .NET 5 and .NET 6. I think .NET 6 is supposed to have long-term support, whereas .NET 5 doesn't. So hopefully we line up our roadmap with that version so we can take advantage of it. Okay. So, unknown and unprioritized wants. Things that have come up from the community that we do not explicitly have any plans for right now. Akka.HTTP. Where does it fit? There's been a dedicated team at Lightbend, the company behind the original Akka implementation in Scala. I think a team of 3 or 4 people worked for several years to build Akka.HTTP. And to some extent, that's because the Scala ecosystem doesn't have, let's say, a canonical MVC framework in the same way that C# and .NET have ASP.NET. That's one reason for it. The other is they basically built an HTTP stack, top to bottom. And I can't remember if Akka.HTTP powers the Play framework, which is another framework that Lightbend produces, which is an MVC framework, or if it's the other way around. I can't remember which came first. In .NET, we already have a really nice first-class HTTP experience with ASP.NET. But having the ability to expose HTTP APIs for actors based on the types of messages actors support would still be really nice. So one of the things that we might look at doing is as we introduce typed actor references, it might get a lot easier to go and develop something like this. We don't need as much reflection magic to go ahead and actually create a set of HTTP APIs that we might support. So we don't really have a clear plan for where we're going to fit this into our roadmap yet. Our roadmap is largely driven by what our users request and what seems to come up in the conversations we have with users in Gitter chat all the time. So if Akka.HTTP is something that's really important to you, I would go ahead and make that case in a GitHub issue or in Gitter chat somewhere. Now, the next bit, in terms of unknown and unprioritized wants, is explicit Unity 3D and Xamarin support. Part of the issues that we have supporting Unity 3D in particular is that everything that we support in Akka.NET needs to be linked up via ahead-of-time compilation, AOT. Reason being is that platforms like Unity and Objective-C not Objective-C, but the iOS runtime for Apple don't really support reflection, like essentially generating code via reflection the way that a normal CLR type can. So this restricts some of the different mechanisms that we have built into Akka.NET that get used today. A good example, receive actors may not actually work all that well on Xamarin or Unity 3D right now because those receive statements we use actually generate some compiled delegates, which are explicitly disallowed by the AOT rules that their compilers use. So we might need to go ahead and add some support to our test suite to go ahead and essentially measure what parts of Akka.NET are and are not properly supported on Unity 3D. We would need to go ahead and have some dedicated tooling support, and not to mention someone on our team would need to own that. So that's something that we are thinking about. Another issue that's come up from some of our users who use Akka.NET for building games is that Akka.Remote is a bit of a problem for building gaming systems right now. Biggest reason is that because Akka.Remote is all about building peer-to-peer connections, meaning we open a socket and we can simultaneously connect to other people's sockets. The fact that we open that bound socket that other processes can use to connect to us, that goes against the grain of some of the limitations that are imposed on client platforms like iOS and Android. So we might need to implement a client-only connection type for Akka.Remote. Well, the truth be told, one of the other things we're planning on porting as part of the Akka.NET 1.4 or 1.5 milestone is Akka.gRPC, a first-class Akka.Streams implementation using the gRPC protocol under the covers. That might actually be a better fit than trying to change Akka.Remote to function in client-only mode there. That kind of skirts the issue of having to rewrite the way Akka.NET's inbound and outbound communication works to support gaming clients. So these are some of the uncategorized issues that we have not quite fit into a milestone yet. If you really care about this stuff and you want to see it in a milestone, The answer is easy. Go ahead and bring it up in Gitter chat and let us know this is important and let us know how this is stopping your business from using Akka.net. That's the sort of thing that'll move the needle for us. All right. Now, let's go ahead and talk a little bit about Akka.net 1.4. What are we working on right now for our users? Biggest ones that we're working on right now is we're encouraging more usage of the setup and actor system setup types. I actually just merged in a pull request, can't remember if it was yesterday or Monday, that basically documents how to use these features in Akka.net now. So for instance, we actually have a type that we introduced in Akka.net 1.4 called a serializer setup that allows you to programmatically express serialization bindings. That way you don't have to do it in Hocon. You can actually do it using delegates in C# instead. So this makes it possible to go ahead and specify essentially runtime bindings, where you don't need to necessarily know what your bindings are at the time your project's compiled and started up. You can actually go and specify it by constructing a serializer setup and merging that into an actor system setup type. The newest version of Phobos, which we haven't really marketed all that much yet here at Petabridge, the newest version of Phobos, Phobos 1.0, uses a custom setup class to pass in a tracing context and a metrics context from app.metrics. And that allows us to go ahead and easily connect the dots between something like your Akka.net actors and maybe an ASP.NET Web API or a SignalR hub, or maybe connecting to a RabbitMQ topic. All those things can be easily connected together now because we can instantiate our telemetry for observing our application's behavior. We can instantiate that outside the actor system, pass those references to all the other components that are doing the tracing and visualization, and then use this programmatic setup class to make sure that all the Akka.net actors are using the same tracing tools that ASP.NET does. So this is kind of a big initiative that we're working on in a few different areas right now. I'd say the next biggest area where it's immediately going to show up is going to be our dependency injection system. We're going to go ahead and try to rewrite that so we actually properly support Microsoft.extensions.di, and we can go ahead and use that as a first-class feature inside Akka.net itself for doing local deployments and that sort of thing. So the next bit that we're going to take a look at is performance. So Andrew has been working very hard on trying to replace .NETty. .NETty has been our transport system since Akka.net 1.2, I think. I think 1.2 is when we first moved on to .NETty. So that would have been, I guess, the very beginning of 2017. So .NETty served us well, but it's showing its age. There's much more efficient ways of doing socket I/O than what .NETty is currently doing. .NETty essentially ported a whole bunch of techniques from Java for doing things like shared memory pooling, that sort of stuff. But now that we have system.memory in .NET, those don't make as much sense. And on top of that, we found a number of performance issues with the way things like the .NETty scheduler work, for instance. So one of the unintended consequences of the Akka.net 1.4 release, where we introduced that I/O batching system, is the amount of idle CPU being used on systems that have fairly low traffic from .NETty is much higher than it used to be because the .NETty scheduler is such a performance hog. On top of that, we've come to the conclusion that the dedicated thread pool we use for running all of the Akka.remote actors and now all the system actors, we've come to the conclusion that that is also a major performance hog as well. And so several of us are all working at trying to A, measure the idle CPU performance, but B, make it better. So we're working on trying to essentially make sure that Akka.net users get a free lunch. The performance of our framework should always be increasing. We want to make sure you can get faster throughputs. We want to make sure we use less memory, and we want to make sure you can get more work done faster with less hardware. So that's one of the things that we're always working on. And I'm sure Andrew and Igor, Gregorius, and Arjun will all agree with me. Performance improvements are always fun in terms of as far as engineering aesthetics go. Those are always fun projects. A couple of other things that we're working on. We just started work on this, Akka.discovery. So Ishmael Hamid, who's one of the longtime sort of Akka.net contributors, he's recently begun porting Akka.Discovery into the core Akka.NET project, and he personally has ported large amounts of the Akka management project. Akka management includes a couple of different tools that you'll find very useful in the course of running a production cluster. One is that Akka management has an HTTP API for managing your cluster. So a lot of the things you can do with Petabridge.Command for doing things like downing nodes and that sort of stuff, Akka management will expose an HTTP version of that will allow you to go ahead and, let's say, use things like a Kubernetes health check, for instance, to go ahead and maybe expose some data about the health of your cluster. So this will be a separate project, meaning it'll be in a separate repository from the main Akka.NET project. But this will consume Akka.Discovery and Akka Bootstrap, which is another project that kind of exists independently of the core Akka project right now. Akka Bootstrap's a Petabridge repository at the moment. We're planning on consolidating all these together into a single Akka management project, which should really help with the operational side of being able to manage Akka.NET clusters in production and get some more visibility into how they're working. So this is something that's actively ongoing right now. Ishmael is leading most of it, but we're going to go ahead and start creating some milestones for this and see if we can get this across the finish line within the next quarter or two. So that's the big sort of open source roadmap for Akka.NET 1.4. We're looking at probably doing releases once a month or maybe once every few weeks, kind of depending on what all's getting fixed. But we're working at a fast clip, and we're working on trying to triage bugs that users are reporting and work on those performance issues as they come up. Now, I wanted to also introduce a couple of things that Petabridge is working on kind of outside the core Akka project, because all of the things that we're working on here are for Akka.NET users specifically. So one request that we've had from end users for some time for Petabridge.Command is the ability to expose a programmatic format for Petabridge.Command. The ability to go ahead and invoke some of its commands programmatically and to get a programmatic sort of rendering of its output. So a good example of this, Petabridge.Command has an actor hierarchy command that can render what the actor hierarchy looks like. Well, some developers might be really interested in getting programmatic access to that, because right now it's all emitted as strings, all that data. Some programmers might be interested in getting a programmatic stream of that data, so you can go ahead and pipe it into some custom system if you want, and maybe visualize all your actor metrics data in there. So Petabridge.Command isn't open source, but it is free. So what we're going to plan on doing here is we're going to introduce a second socket that Petabridge.Command.host will open, and this will allow you to interact with Petabridge.Command using protobuf messages. So to use a similar design to what Petabridge.Command has today, where you define the commands your system supports on the server, the client can download them and memorize them, and then can generate those commands and send them back. We're going to go ahead and continue to support that for the programmatic version of Petabridge.Command. The one difference might be is that you actually might have to, if you want to programmatically consume Petabridge.Command, you might actually need to go ahead and install a NuGet package to be able to do that. And that NuGet package will allow you to go ahead and essentially get a typed object that you can use to go ahead and submit commands programmatically to the server, and you can get a response stream back. So this is something that we're looking at doing. We actually need this for the second thing we're going to announce, which is a cluster visualization tool. In addition to the binary message format that we're working on for Petabridge.Command, we're going to be building some new modules. One is for Akka.Cluster metrics. This will allow you to get real-time CPU memory utilization for all the nodes in your cluster. In addition to that, if you create any sort of custom metrics, a good example might be, if you're using RabbitMQ, maybe you might want to go ahead and measure the queue length of each of the nodes that are writing out to it. I just made that up. I don't know if that metric actually makes sense in real life for most use cases, but whatever. The idea is that we're going to be able to expose this sort of metric data about the shape of your cluster via the Akka.Cluster metrics module for Petabridge.Command. We're also going to introduce a module for Akka.Cluster tools. In particular, what these modules are going to do, they're going to be able to tell you the location of where singletons are inside your cluster. They're also going to have the ability to go ahead and tell you the number of topics and subscribers for each topic inside the cluster. We're going to add some diagnostic tools for being able to render some of that. So these are some of the things that we're working on cooking up behind the scenes. We're also going to expose, for people who are Phobos customers, we're going to expose a Phobos module that'll go ahead and emit some of the metrics that are being captured by that system as well. So if you're interested in knowing about the number of underlying, messages of this type per second processed by your actors, you'll be able to get that data out of Phobos. Now, the last thing we wanted to talk a little bit about as part of the 1.4 roadmap here is the Phobos cluster visualizer. This is a work in progress name. We might change it. It's going to be a standalone .NET Core web application that you can deploy via a Docker container, or you can maybe we'll have some way of allowing people to host it via a Windows service. That's another way of doing it. And this is going to visualize the state of Akka.NET cluster health using Petabridge.Cmd streaming commands. We're going to include the live state of the cluster in terms of what it looks like right now. We're also going to go ahead and include the prior state of the cluster. We're going to show what your cluster looked like 2 hours ago, or really that's going to be kind of an arbitrary window of time. That way, someone on your ops team can go through and get an idea of what may have happened to your cluster over the past, let's say, a couple of hours worth of runtime. So the other bit is, because we're able to go ahead and essentially observe, your current cluster health, we're able to receive notifications from Petabridge.Cmd about how that health might change. We're going to give users the ability to create alert rules. These alerts will probably just invoke webhooks. So you can go ahead and have a alert that goes to a Slack channel or Microsoft Teams. Maybe we'll add support for SMTP. So maybe we'll send out an email alert when something happens. But you'll be able to go and specify your own rules. So for instance, if you're using Akka.cluster roles, you might go ahead and have let's say, a rule that says, hey, if we drop down to fewer than 2 nodes of this role type, I want to receive a notification back. This is the type of rule that'll be supported inside the cluster visualizer. We're also going to enable the cluster visualizer to consume data from Akka.cluster.metrics and Phobos to help show how busy different nodes are inside the cluster. So this is going to be a standalone web application that connects to your cluster via Petabridge.Cmd streaming commands. Now, this is a proprietary product that Petabridge is working on, but there's going to be a free plus a paid tier. The free tier is going to basically say that we're going to allow only one concurrent user to go ahead and look at the web UI at any given time. This is similar to what tools like Seek do if you use that. And then we're going to have some custom alert rules. We're going to limit it to just one set of custom alert rules for our users. And then we're not going to store any prior cluster history. You're only going to be able to see what the live state looks like. You might see some alerts that fired in the past, but you're not going to be able to go back 4 hours in time if you don't want to. The paid tier is going to cost $1,000 a year. There's no limitation on the number of nodes in the cluster or anything like that. And that's going to require a live license that's going to be validated via the SDK bin API. All this stuff might be subject to change. We're hoping to do this to ultimately help fund more engineering positions here at Petabridge that can allow us to do more work on the Akka.NET project. So we think that having a combination of free and paid is probably a good compromise here. So we'll see how things go, but that's going to be part of the that's going to go ahead and be part of the mix of things that we're working on right now. Now, Vagif, I saw that you asked a question about the F# API, so I wanted to just jump to that real quick. As part of Akka.NET 1.5, we're going to reshape the F# API. The F# API has not really been touched all that significantly, really since Akka.NET 1.0. I know Bartosz has had the Akkaling project, where he's done a lot of work on experimenting with new concepts there and trying to come up with more idiomatic ways of doing things in F#. Our goal is in Akka.NET 1.5, we want to go ahead and reimagine the entire F# API. That way, we leave developers who are using untyped actors with a good experience. All this we want to do prior to Akka.NET 2.0, but we're going to be using typed actor references predominantly everywhere. So this is on the roadmap. We have not forgotten our F# brothers and sisters. Now, for Akka.NET 1.5, in terms of the roadmap here, the big things we're looking at is the artery transport for TCP. This is going to be built on top of Akka.Streams. It's going to have better support for larger messages and connection multiplexing than what we have today. So you're not going to be limited to the rate at which bandwidth can be transmitted over a single connection in Akka.NET 1.5. We're going to have the ability to do certain types of connection multiplexing. Large messages are going to be handled out of band so they don't block the channel for the rest of your user messages to pass through. And message order guarantees are still going to be preserved. So our current plan is to make Artery opt-in for Akka.NET 1.5 at the very start of it. So our hope is to release the first Artery transport, have people start opting into it, have them start giving us feedback on how well it works. And then by the end of the Akka.NET 1.5 maintenance lifecycle, our goal is to go ahead and enable Akka.NET 1.5 by default everywhere. That way, essentially, we can deprecate the old Akka.Remote classic transport that we've been using for so long, and we can go ahead and just have everyone running on Artery by default everywhere. We think this will ultimately result in a much better experience for Akka.NET users on large. Akka.Streams modernization. One of the big things we need to do is replace the materializer and a couple of the other sort of internals behind Akka.Streams. This should make it more efficient to materialize fairly complex graphs is one of the things going on there. But it should also be a lot better about optimizing certain types of streams and everything else. So this is kind of a big requirement that we need to do anyway as part of getting Artery out the door. Standalone Hocon, we're going to try again. We learned our lessons from trying to integrate Hocon 2.0 and Akka.NET 1.4. Our hope is to go ahead and lay the groundwork for Hocon linting and analysis tools. We're going to have built-in environment variable substitution. And we're also going to have a Microsoft.Common configuration adapter that we can use for passing in Microsoft.Common.configuration values into areas where Hocon would be used. So we're going to go ahead and do a fair amount of engineering work around this. These are all ideas we experimented with as part of Akka.NET 1.4. I think we've learned how to do them a bit better. So we're going to take another pass at this as part of Akka.NET 1.5. Multi-data center support. So we're going to go ahead. This is something that Bartosz originally ported to Akka.NET, and it's been in a pull request for at least 2 or 3 years. But the problem is that it touches so many different things, and there were so many other things going on at the time that came up, because I think that was part of the Akka.NET 1.3 milestone originally, that we decided just to defer it, and we decided to defer on it again as part of Akka.NET 1.4. Well, for Akka.NET 1.5, we're really going to do it, and we're going to go ahead and essentially go through the trouble of making sure that all of the features that are built into Akka.NET, such as distributed data, cluster sharding, cluster singletons, all have proper support for being able to name different data centers. So this should make it possible for a whole bunch of scenarios that customers are currently doing somewhat cumbersomely with a single cluster right now. This should make it a lot easier for us to go ahead and have full-fledged support for large-scale clusters that span multiple data centers. So this will be pretty similar to how you declare roles in Akka.NET Cluster today, where inside your Hocon, you're going to have the ability to go ahead and name a different data center. So you can say, this node is going to run in US East 1. This node is going to run in Europe, Western Europe 1. This node's going to run in Australia 2, whatever the case may be. And then the different routing mechanisms for communicating both between data centers and within data centers can factor in, where is this node relative to me? If it's in the same data center, I'm going to give that node priority when it comes to communication and redistributing entities and that sort of thing. If this node's outside the data center, I'm probably going to communicate with it less frequently, but I'm still going to want to communicate with it periodically, so I know that node is synchronized with me when it comes to sharing state for things like distributed data, or maybe when it comes to just sending commands and messages back and forth. And then, like I mentioned earlier, the F# API is something that we're going to redo. The next big thing that we need to deal with is default serialization. Hyperion has been the solution we've been looking to for a long time. And we have a lot of users who are using it. So we do want to honor our word here and try to make that the default for serialization going forward for Akka.NET. But there's a couple of downsides. First is that Hyperion and really our current JSON.NET implementation are vulnerable to type injection today. This is because we don't have any type of filter or, let's say, whitelist mechanism to say which types can we serialize and which ones we can't. The fact that we now have programmatic serialization bindings should make it a lot easier to express that type of information now. So we can go ahead and say these are the types that are allowed and these are the types that are not. So we have the ability to make that a lot easier today in Akka.NET. The downside of Hyperion is that because we're the ones ultimately on the hook for maintaining it, it's a significant cost to the Akka.NET team. And no one really owns it inside our organization right now. So that's something that we're going to need to, that's something that we're ultimately going to go ahead and need to resolve, is we're going to need to decide, all right, is this going to be the way we go forward? Are we going to go ahead and try to find some way to make the 0.9 version of Hyperion backwards compatible with the 1.0 version? Are we going to implement a proper wire format for this? These are all some pretty big ticket questions. The other way of potentially handling this issue is changing our wire format altogether to use something like CBOR, which is it has a stable RFC, has a bunch of robust implementations, is very performant, is much more secure. But the downside is it strands all of our users who've been depending on Hyperion for years. So I will promise this much. In terms of part of our sort of professional, open source guarantees, we will find an upgrade path for anyone who's been using Hyperion to either move on to Hyperion 1.0 or CBOR or whatever else it is we come up with. So we're going to make sure there's always a migration path because that's just in our best interest to make sure that's the case. And we always want to make sure we're careful with the promises we make to end users. So we're always going to go ahead and make sure we have some way of doing this. It's in our reputational interest to do that. And it's also in, speaking as the CEO of Petabridge for a second, it's in our financial best interest to make sure that's true. So regardless of what the technology choice ends up being, we're kind of weighing a few different options right now. We will make sure there's a migration path onto it. So that's so if you see this slide and this gives you butterflies in your stomach, fear not. We are going to find a way to make sure that everyone who's using Hyperion right now, either we have some way of making the new Hyperion backwards compatible with the one that's been out there today, or we have some sort of adapter that allow you to switch between Hyperion and CBOR. So no worries there. The other big thing we're going to look at for Akka.NET 1.5 is Akka.Streams gRPC. So as part of the Akka.NET 1.4 release, we launched the Akka.Streams.Kafka handle, which was essentially a full-blown set of streams adapters for reading and writing back and forth to Kafka using a variety of syncs, flows, and sources. We're going to do the same thing with Akka.Streams gRPC, and this is meant to be a catch-all integration point for communicating with Akka.NET clusters externally. So for instance, this might be the solution that we recommend for allowing users to safely communicate with an Akka.NET cluster from inside a Xamarin application that's running on someone's phone or a Unity 3D game or whatever. We will probably also be pushing users to use this integration instead of using the cluster client. We're going to go ahead and essentially, push users towards maybe using Akka.Streams at gRPC instead of cluster client for working with our clusters. Now, we're not going to get rid of cluster client. We're going to keep supporting it. So this would be more like a practical replacement, not a literal replacement, meaning that the old code will still work, but we're going to, in our documentation and in our literature, we're going to encourage users to adopt Akka.Streams gRPC instead. So that's the full menu of things we're looking at for Akka.NET 1.5. Delivery timeframe for this is Q3 of 2021. I would love to be able to get these things done sooner, of course, but working within the set of constraints that we have right now, this is what we think is achievable. This is a time frame we think is achievable for all this. Let's see. Now, if you have questions, go ahead and leave them for me in chat. I'm taking a look at them, so don't worry. I'll make sure I get to those. But the really big thing I want to talk about is the future of Akka.NET, which is Akka.NET 2.0. I think I put Q3 2022. I think in a couple of others I said Q2 Let's split the difference and say it'll be somewhere between those two values. Akka.NET 2.0 is something that I have personally wanted to work on for a long time because, in my opinion, it solves what is the biggest drawback of Akka.NET today. The biggest drawback of Akka.NET is the fact that you get all this amazing, flexible, high-performance behavior, but that comes at the cost of not being able to understand what your code does when you read it. It's a classic example of a dynamic typing problem, is really what it is. So we're going to follow in the footsteps of what the Scala project did, and we're going to introduce Akka.Typed, which is going to give us the ability to expose statically typed actor references that express the messaging protocols these actors support. So a statically typed actor reference basically declares, I receive this input and I produce this output on it. So you can look and use static analysis to make sure you're talking to the right type of actor just by looking at your source code. And we'll be able to go ahead and use things like Roslyn analyzers to verify the correctness of your code before you even deploy it. Now, I actually have some slides here that prototype the programming model of what this will really look like. That way you don't have to just imagine it. You'll be able to see it in a couple of moments here. Now, these actors, these typed actors are composed via behaviors. Behaviors are basically a way of expressing what an Akka.NET receive looks like. So essentially we have, receive statements inside of receive actor today. That's going to be transformed into a behavior where it's an input and then somewhere between 0 and n outputs that are going to be produced back out. And these behaviors allow us to unit test how our actors work without actually having to go and spin up the Akka.NET test kit. We can go ahead and really simply test our actors using normal synchronous unit tests without needing to go ahead and write an Akka.NET test kit for this stuff. On top of that, the other thing that Akka.Typed makes possible is the notion of a stateless actor. A stateless actor functions like a router, where it doesn't have a mailbox. Because stateless actors have no side effects, they can process multiple messages concurrently. So this means that actors that do things like, let's say, saving data to a database using some sort of repository, or maybe actors that do things like validation. You now can have one instance of the actor who can process an unbounded number of requests concurrently. So an actor doing something that's very computationally inexpensive, a stateless actor can process 65 million messages per second versus 5.5 million messages per second using Akka.NET 1.4. That's a gigantic difference in speed, and that's because one of these actors is running concurrently because it's stateless and has no side effects. So Akka.Typed makes it very easy for us to differentiate between stateful and stateless actors, which is why we can get away with this. Now, the other major highlight of Akka.NET 2.0 is we're going to move on to .NET 5 and .NET 6 only. We're going to rewrite the I/O layer, serialization, and remote pipelines to use system.memory primitives. We're going to focus much more aggressively on zero-copy data structures, particularly in areas like our networking pipeline, so we can try to squeeze way more performance out of .NET than we are currently right now. A lot of our sort of legacy systems that are built into the core of Akka.NET are all built around what was essentially in style at the time during .NET 4.5 when that came out. So we want to go ahead and rewrite some of that when .NET 6 comes out in particular, because that has long-term support to take advantage of a bunch of these new native I/O primitives under the covers. Now, a couple of other things that you should know about Akka.NET 2.0. We're going to add typed actor reference support to all the major modules. So Akka.Cluster, persistence, cluster sharding, all that stuff. And we're going to go ahead and document all of our examples to kind of help guide users towards using typed actor references. Classic Akka.NET applications that you have right now, meaning ones that are untyped, where you're using receive actors and untyped actor references, those are still going to be wire compatible with Akka 2.0. And basically an untyped actor reference is still going to be able to work with a typed actor reference. This is something they solved in the original Scala project. And because, you don't want to make it so everyone who's writing Akka.NET code today, we don't want to make it so all that stuff has to be rewritten with typed actors. That's not economical or practical. So there's going to be an adapter and a bridge that allows you to convert freely back and forth between those. So it's worth noting that even though one of the biggest reasons why we want to do this is to make it feasible for people to move on to Akka.NET 2.0 without having to rewrite everything they wrote in Akka.NET 1.5 and earlier. The other really big reason we want to do this is there's a bunch of Akka.NET internals that we do not want to rewrite using typed actor references. The internals of things like Akka.remote and Akka.persistence spring to mind down here. So this is sort of the big roadmap for the future here. Now, I'm going to go ahead and walk through a little proof of concept of what typed actor references might look like. So one of the things that we're going to do is that we're going to go ahead and introduce some new interface types in Akka.NET. The iRecipientRef interface, which is going to go ahead and say, you can tell me a message of type tMessage. So all of a sudden, tell goes from taking an object to taking a concrete generic type. We're also going to go ahead and expose the actorref type. And by the way, this actorref is going to go ahead and bind to a message type as well. And it's going to expose an actor path. So any actors that implement a behavior of type tMessage, where behavior basically helps us define how we process one of these messages, will produce an actor reference that implements iActorref tMessage. And actors can only implement a single behavior, but that behavior can process multiple messages that derive from tMessage. So tMessage in this case is going to be let's say a super type that defines multiple different messages that are all part of the same protocol. So here's a good example. Oh, actually, sorry, I haven't gotten to my example yet. This is still leading up to it. So we're going to also take a lot of the, let's say, lifecycle and behavior events that we used to have in Akka.NET Classic, such as pre-start, post-stop, all that sort of stuff. Those lifecycle events are actually going to become messages in Akka.NET 2.0. Where we're going to go ahead and basically have behaviors that we can implement. Well, I can go ahead and receive a message, and this message is going to come with a typed actor context, which tells us who the sender was and everything else. And we're also going to be able to go and process the message. Our behavior is also going to define how we handle signals. So these signals look like things like restart or post-stop, that type of stuff. So we're going to go ahead and have essentially a new set of constructs that are going to make it so we can still handle the previous lifecycle methods that we had before, but those are going to be done via messages now. That way, all that behavior can be self-contained inside these new behavior classes. The actor context is also going to be typed as well. So you'll notice we don't have a sender anymore. The actual sender for these messages that we pass around has to be defined in tMessage here. So that way, the actual messaging protocol needs to include directions on how to, directions on basically who we should reply back to. This is all part of the type system that we're trying to encourage through Akka typed. Ask is now going to include a static type for the response and a type for the request. And it's going to have a number of different little methods for converting, let's say, a response back, including an errored response back into the protocol of this actor. All actors are going to have a logging adapter on their context. And we're also going to have a way to refer back to ourselves, way to refer back to the actor system, and so forth. Now, here's an example of what a messaging protocol might look like. I'm going to create a class echo where my input's a string, and I'm going to include a typed actor reference of type echoed back here that we can reply to. And then I'm going to go ahead and create an echoed type here that takes a message, and also is going to go ahead and take an actor reference of who we receive this message from. Well, if I want to go ahead and build a new echo actor, I'm going to subclass this abstract behavior right here. And I'm going to go ahead and override my little create receive. And we're going to create a new message builder right here, where we're going to go ahead and say on message echo actor.echoed, and we're going to pass it into this little private behavior right here. And this behavior is going to basically be, something that we implement, like some little class that we go and implement under the covers here. We're basically going to be using tail recursion to go ahead and drive how we actually receive messages inside Akka.NET going forward. So if I want to go ahead and have the actors shut down, I just go ahead and return behaviors.stopped. If I want to go ahead and reply back and get ready to receive the next message, I go ahead and do message.from.tell new echo actor.echo. I pass in a reference to ourself, and then I go ahead and return this, and I'm ready to receive the next message again. So by the way, behavior switching, we don't need to have become, become and unbecome, all those sorts of methods we had before. We can just switch behaviors by returning a different one than what we had before. So building finite state machines is now something we can actually type check along the way as part of typed actors. Now, this is just a rough prototype I put together, working backwards from sort of how things are expressed in the Scala implementation today. The real version of this that we start to deliver as part of Akka.NET 2.0 can change. But there's a lot of possibilities that are available as part of this. The biggest one being that we can now type check all of our actor work across the entire cluster. So our plan for trying to deliver Akka.NET 2.0 is we're going to start with a proof of concept that's developed out of band with the primary code base. Reason being is we want to continue our long-standing policy of not doing giant pull requests all at once. We are not fans of those in the Akka.NET project because they're impossible to review correctly. And there's many different ways we can go about accomplishing building typed actors. Right now, the approach I was using was basically simple composition, but it's also possible we could do things with code generation or maybe using reflection to go ahead and generate typed actor references and bindings based on behaviors. I think we'll probably stick with simple composition though, since that is probably the most AOT friendly, which is something that we do want to try to accomplish down the road. Now, I already kind of talked a little bit about this, but I'll rehash it again. Why do we care about typed actors? Why is this a thing? Well, the biggest thing is that it improves code cohesion, forces developers to build explicit protocols that are enforced by the type system. So I'm sure the F# developers in the audience are cheering because this is something that they're kind of used to anyway. And C# is moving in this direction, by the way, where we're gonna move into a lot more sort of functional style programming, where a lot of the protocols that we build are much easier to capture in the type system. Typed actors are a natural expression of that idea. It's also going to remove a whole bunch of the implicit magic that happens inside Akka.NET today with things like the sender and some of the envelope data. We're going to make those relationships explicit and defined via the type system so they can be checked. The other really big reason for this is this will massively improve productivity. Behaviors can now be tested independently from actors. That is huge. That'll make it significantly easier for us to test actors and to be able to go ahead and verify that all of our code is safe. It'll also make it much easier for us to use tools like Roslyn analyzers to be able to go ahead and detect whether or not our applications are valid, whether there's situations where we might deadlock, or situations where an actor might be waiting forever for a response it's never going to get. There's a lot of different things we can do now that the type system is back in the picture again with Akka.NET. Now, the last handful of other major Akka.NET 2.0 changes. This is something that we've actually been discussing this week. We're going to modernize the dispatcher system to use some of the new primitives that have been introduced in .NET Core. In particular, we're going to replace mailbox.run with a method that returns a value task. Essentially, the way actors are going to process messages now is they're always going to be processing a message inside a task, which means that any asynchronous operations we start while we're inside an actor are going to automatically be scheduled onto that actor's dispatcher. So I can make sure that all the I/O work happening in Akka.Remote, all those tasks for reading and writing out to the socket, all those get managed by the same group of worker threads that are independent from the ones who are handling Akka.Persistence. So we have better segregation of responsibilities that way. We think this will be easier to maintain and ultimately more performant, but we obviously need to benchmark all this. And in the event of a catastrophic loss in performance, we'll probably ditch this idea. But this will go ahead and make it so Akka.NET dispatching systems will play really nicely with other synchronization primitives inside the .NET ecosystem, such as flowing context and async local. As someone who spends a lot of time working on Phobos, which is all about correlating activity that happens inside Akka.NET with activity that happens elsewhere, making it easier for us to support open telemetry in Akka.NET with async local by changing the way our dispatcher works. This is a huge benefit to us. It'll make it a lot easier for us to go ahead and correctly correlate things in there. But as Arjun and some of the other members of the team have pointed out, this is way too dangerous to do inside a minor version release of Akka.NET because there can be all sorts of unknown side effects that are very difficult for us to predict before we do it. So we're going to try to introduce this gradually as part of Akka.NET 2.0. Last thing I wanted to touch on before I take some questions from the audience today is documentation and examples. We're already doing this with Akka.NET 1.4. I went ahead and pushed some documentation that describes the new scheduling APIs we introduced in Akka.NET 1.4. We've also pushed some documentation explaining how to do programmatic serialization bindings. Gregorius and Igor on the Petabridge team are working on updating our Akka.Cluster workshop at the moment to go ahead and modernize some of that. We're going to write some more documentation around best practices for cluster operations. So there's some incremental work going on here. Knocking out at 1.5, we're going to essentially continue what we're doing right now. But with Akka.NET 2.0, with the introduction of typed actor references, we're going to need to redo and revisit everything. Akka.NET Bootcamp, the cluster workshop, the website, all of it is going to be rewritten from the ground up. So these are ones that we're going to go ahead, and this is sort of what our roadmap is for trying to approach all these things. It's ambitious. It's going to take somewhere in the order of 1 to 2 years to do all of this, but we're very encouraged to do it by the members of our community, by our contributors, and by the other folks in .NET who are generally just fans of the work that we're doing. And we're doing all this ultimately to help build better tools for developers like you. So we really appreciate your time sitting through our presentation today. And without any further ado, I will take some questions from the audience. So let's see. What do we have? Question from Michelle. Let's see. Your question was, are there any plans for Dapper integration? So Dapper is Microsoft's cross-platform actor framework, which is, I kind of think of it as Service Fabric, but for Kubernetes. It's kind of my sort of layman's way of thinking about it. At the moment, there isn't. That's the first time that's come up. But if you wanted to go ahead and put together an issue detailing some of the things that would be useful for you to see and why you'd want to see it, and if there's some other users who feel similarly, that is something we can always think about putting on the roadmap. We're very much driven by the feedback we get from the users. Let's see. Laden, you mentioned that you want to have a proper forum because Gitter has been horrible to search for info, and I feel like a proper forum would really help the community. I think we could go ahead and use GitHub discussions for that. I think we need to opt into a beta for it, but that's a really good suggestion. And I think that's something that we actually really do need. I think GitHub discussions would be, or some type of forum would be really useful for us. We used to have the Google group for doing some of this back in the early days of Akka.NET. And I think it'd be really useful to have something like that back again. So I'll go ahead and make a note on paper here to go ahead and look at GitHub discussions. Okay. I think that's the end of my presentation here, just about. All right. Are there any other additional questions from any of the other members of our call today or from the community? Okay, I saw message versioning practices. Well, I'm going to go ahead and end my screen here. So for message versioning practices, we do have a bit of material on the Petabridge sort of cluster training course. Let me go ahead and pull this up real fast. We do have some guidance on how to do this. I think it's part of lesson 3. So, by the way, if you didn't know this is a course we haven't promoted all that much. It's basically Akka.NET Bootcamp for for doing Kubernetes and Akka.Cluster. This is the thing I mentioned that Igor and Gregorius were actually updating. I went ahead and just dropped a link to that in chat. If you want to go ahead and look through this explains how to do version tolerant sort of iteration of messages using Google Protocol buffers under the covers, which is the technique that we recommend because it gives you explicit control over how things get versioned as you update your message formats over time. Next question from Razvan. I've been interested in contributing in some form, been using Akka in a few projects since 2016. How should I proceed? That is a fantastic question. So the first way I would go ahead and try to get involved with Akka.NET is I'd go to our Issues tab here. And by the way, here's something that we're going to work on. I would do one of two things. First is I would take a look for, let me go ahead and search real quick by label. Let's take a look for, I think it's help wanted. Yeah, let's take a look. Help wanted. All right. So we have a handful of, let's say, open issues here that we need to go ahead and fix. A lot of these ones are designed to be fairly self-contained issues. So for instance, this one, turn off debug logging for all multi-node specs. That's an issue that would probably not take a huge amount of time because it's a fairly self-contained issue. But this would also reduce the amount of time we spend building the multi-node tests by probably about 10 minutes. So that would be really useful. That's one thing you can go and look at. Another thing you can look at is the milestones. So the way we tend to organize milestones, and we're going to change this slightly. We have a set of milestones for like open issues we want to go ahead and close out for the next release. And then we have a second milestone for future things we're planning for a much larger milestone. So if I click in here, you can go ahead and take a look and see some of the open issues that are in progress right now. And most of these issues are unassigned. Up for grabs, by the way, is another issue, another type of label you can take a look at. So yeah, we have a whole bunch of up for grabs issues right here. In fact, I'll drop a link to this in chat as well. So if you want to take a look at some of these up for grabs issues, that would be very useful. So good example. If you want to go ahead and take a look at, we need to add read majority consistency to distributed data. You can take a look at what Gregorius wrote here, and you can see that we added the required protobuf format here. And I think he also links to some of the relevant Scala code where this is implemented. And as you can see, we've been trying to do this for a little while here, and we keep pushing it to all these new releases. That would be a great way of getting involved too. One of the things that we are going to work on as part of our community stuff, if I click on this, these are some of our meta issues that I opened a couple weeks ago. We're going to go and implement some of these that should make it easier to answer this question going forward, which is, if I want to contribute to Akka.NET, what's the right way to do it? We have some documentation today that explains some of the conventions and practices we expect if you're going to contribute to Akka.NET. If you go to the Akka.NET website and you click on Community, and if you go to, let's say, Building Akka.NET and Approving Public API Changes and Contributor Guidelines and Documentation Guidelines, we do have a little bit of information on what to do here. We're going to revisit all of this over the next couple of months to go ahead and try to modernize it. For instance, these coding conventions are from 2014, and I don't think I've ever used almond-style brackets for C# code. Let's see what that is. No, I guess I do use almond-style brackets. I thought it was the other way where it goes up here. Whatever. This is stuff that we're probably going to go ahead and redo to some extent. But these are some things we're going to go ahead and talk a little bit about in terms of, okay, if you want to get your pull request accepted, what are some of the things you should do? So good example, if you want to go ahead and make changes to the public API, this is a document that you're going to get sent the first time you go ahead and make a change to Akka.NET without, let's say, checking in your API approvals first. And so these are a couple of things you might want to take a look at. Let's see. Are there any additional questions for today's meetup? Nope. Well, if that's it for today's meetup, then I really appreciate your time. You'll go ahead and see us in Gitter chat or perhaps GitHub discussions if we were able to go ahead and enable that. We really appreciate everyone in the Akka.net community who's been active in GitHub or in Gitter or on Stack Overflow. You're part of what makes the Akka.net project a really fun place for me to work every day. So I really appreciate it. And we thank you for your attention and for your time on this call today. We look forward to getting all this work done against all these roadmaps and making Akka.net a better and more fun project every day. Thank you very much for your time. Appreciate it, everybody.